Alright then guys, so for this video we're going to look at creating some doors that will be controlled by different color keys dependent on the actual color of the door itself. So first things first, we're going to have a look at actually creating the materials. So I've created a new folder just called Lock Door, which is going to contain all of the assets. I've already obviously got them in the project, but I'm just going to kind of re-import them just to go through how you would actually bring them into the project. So as always, keep things nice and tidy. We're just going to create a system of folders. So we'll just right click, create a new folder, which I'm going to call materials. And inside this folder, I'm just going to create a new material, which I will call key and door base. So the idea here is we're going to create a base material and then create instances which we'll use to configure the individual types. This is a nice way to create materials where you do a lot of setup on your original material, and then the instances you can use to change to provide a bit of variety throughout your level. So we'll double click on this material just to open it up, and what we're going to do is we're going to have a look at the metallic, specular and roughness. We will create some scalar parameters which will wire into these properties, which will allow us to configure the kind of shininess and look of the material. We'll also create a base material again with a configurable color, which we'll be able to change within the each instance. So we'll start by just creating our configurable properties. So if you just want to right click, type in scalar, and just make sure we give these names as we create them. So this one's going to be our metallic, and you can right click and recreate another one, but a nice little shortcut is just to press Ctrl W. So just make sure you move your mouse somewhere within the area. Ctrl W will add a new material, a new node. So we're going to call this one specular, and third one which we'll call roughness. Just missed the R out there. Roughness. So we can wire these parameters in. Just click and drag to create them in. And for the base color, I want to create a nice metallic material. So I'm just going to minimize this window a little bit. And if you've created your project with the starter content, if you have a look in the textures folder, you'll see there's quite a lot. We're going to just add, let's have a look, where was it? We're just going to add the T Metal Gold D as a texture sample, and the T Metal Gold N. Now those suffixes just refer to which type of texture these are. So the N is the normal map, and the D is the diffuse. So the diffuse is going to provide the color, and the normal is going to provide the bump. So we can just wire that normal texture straight into the normal. And in terms of the color, instead of just wiring this straight into here, we're going to create a vector node. Let's have a look. A constant vector 4. Sorry, not 4. Constant vector 3. Let's have a look. One second, just refresh my memory. Vector parameter. Okay, so vector parameter. So this vector parameter will be configurable. Now we don't need to change the color for this, but what we are going to do is just right click and create a multiply node. And the multiply node will take the color from the vector to multiply over the texture of the gold, and that will feed into our base color. So if we just wait for this to update, my laptop's a little slow. Might need to, oh, there we go. Right, so because it's black, let's just provide a color just to show off a little bit what it's going to look like. It's a little bit slow. Just let that come up. There we go. So we've got, you can just see some of the detail from the normal map showing through there. Obviously our metallic, specular and roughness will change the overall appearance. So I'm just going to set that back to black. There we go. And we'll just save that material. It does take a little while to save materials. There we go. So back in my materials folder, to create the instances, we just right click on the material and create material instance, and we'll rename these as we go. So we'll call this one red instance, green instance, and blue instance. So just double click and you'll see that you get a much kind of leaner interface, and all we need to do is just tick on the parameters that we want to configure. So for the red instance, we'll just ramp up the red color. You see that you get the result kind of loads up a lot quicker, but just have a play around with each of these scalar values until you get a result that you like. Just change that specular up a little bit as well. So you do want to be careful, you don't want to have too much shine. The shinier the materials, the more shiny materials within your scene will take longer to render, more computationally expensive. So let's just quickly configure these materials. So the same thing again, just turn on each of your materials. Let's just set this up to be green, the green instance. Let's just type in some values here. Roughness 2, specular 0.5. There we go. So let's just configure the blue as well. There we go. So just make sure we turn these all on, and I want a nice color for the blue. And let's just ramp that up a little bit as well. Maybe a little bit of a lighter blue. There we go. Perfect. So that's all of our material instances done. So let's just go back to our Lockdoor folder, and let's just, again, to maintain tidiness, let's just create a meshes folder. In the meshes folder, we're just going to import our FBX file. So our key pickup, just import, and this is just a result of the modeling. It's not a critical error, so we can just ignore that. Let's have a quick look at the actual static mesh. Oh, it's just a nice simple key. And we're going to create, before we create our blueprint, we're actually going to create a enumerator asset. Now, the enumerator asset basically just allows you to specify specific values to given indexes, so starting from 0, 1, 2, 3, 4, 5, so on. You can assign specific values to each of those numbers. And we're going to basically wire this in to the construction script of our blueprint, which will allow us to essentially change the color of each of our doors and our keys within the editor. We can basically have one blueprint set up, which we can then change later. So we're just going to call this door and key enum. And if we just open this up, you'll see it's a very simple interface. We just want to hit new a few times. So we can specify, in fact, we probably don't need that one. So we're just going to create our 3 colors, red, green, and blue. Save that off, and we can close the enum down. So this is going to be used to factor in for our colors of our keys and doors. So I'm going to create our blueprint class, and we don't need any special functionality with this, so we're fine with just using the actor as our parent class. So we're going to call this one key pickup and just BP at the end, just to maintain naming conventions. So if you double click this, just to enter into our blueprint. So the first thing we're going to do obviously is add our components to create our object. So if we add a component, we want to bring in a static mesh, which is going to be representative of our key. And again, just for the sake of tidiness, let's keep everything named as we go. So we can call this key SM for static mesh. And we'll also create a collision object, box collision, which will be used to calculate whether or not we've picked the key up. So we can rename this to key collision. Okay, so the key static mesh, at the minute there is nothing within here. We need to specify which mesh we want. So we'll just open the drop down, just type in the word key to get our static mesh. And the model itself is a little small, so let's just ramp up the scale here. Now normally I wouldn't do this, I would return back to your content creation program just to kind of reconfigure, but for the purpose of this we don't really need to kind of worry too much about scale factor. So we're just going to make the collision box a little bit bigger as well. If we have a look from the front, we can do with just making the collision box a little bigger. And for this, we're not going to use the scale, we're going to use the box extents. So we'll just make it a little wider on the X. The Z value is fine. Let's just have a look back in perspective mode. And yes, that will do. That will do. Probably bring the Y extents a little bit smaller. We don't want to have too much of a large area before we actually hit the key, before it disappears. So that looks good. Now, similar to what we did in a previous session to get the key a little bit animated, we can have a look at setting this up. So I'm just going to make the key collider a child of the static mesh, so that the key collider will follow any animation that the key has itself as well. Okay then guys, so just jumping back into the construction script, we are going to drag from the construction script, and we want to set the material. And in terms of the target, we want to make sure that it's the key static mesh. And we don't want to actually set a material here. We want to be able to change the instances that we created earlier. So from the material node, just going to drag. We're just going to add a select node. And don't worry about these options here, these will auto-populate when we drag our enumerator variable in. So the enumerator variable, we can just drag this in, and we want to get. And the enum is what we're going to wire into the index, and you'll see that our the values that we set in our enumerator will show up. So we just want to select which asset we want to load based on the value that we select. So if we load in the red instance for the red, green instance for the green, and the blue instance for the blue. There we go. So compile that. We've made the enumerator value public by just ticking on this little I symbol here. This will allow us to change our values. So by default, the door will be red when we create it, but we can actually select from a drop down to change the value. So you'll see when we go back to the viewport that our key is now red by default. So if we jump into the event graph, let's have a look at setting up a little bit of animation. We don't need the event begin, play, or overlap, so we can just delete those and get rid of those. But we will need our tick, which will provide an update per frame, which will facilitate the animation just to get everything working. So we want to drag from the event tick. We're just going to click and drag, and we're going to create a timeline node. So we'll just type in timeline, and it's the very bottom option you want, the one with the little clock symbol. Let's just rename this to up and down motion. And the timeline effectively dictates the interpolation of the objects that we want to move. So if we double click on this, it will open up the timeline within a new tab. At the minute, there's nothing here. We need to tell it what type of timeline we want. So we want to have a flow track. We can rename this, so our flow track will be the up and down motion, and it's important to give this a name that means something, because this is essentially this is our float output that will control the alpha of the loop from our two positions. So we want to create on a timeline some keyframes. So firstly, we're going to set our length. So we'll set it to something smaller, such as 2. It's 2 seconds long. And we want to create a keyframe at frame 0. So we right click, add key. And if you don't get it quite bang on, you can actually type in the value that you want. So 0 for time and 0 for value. About half a second in, we're going to add another keyframe. Again, we can change the value, and we want to change the value of this to 1. So it will spike up. So if you need to move around, you can use your scroll wheel to zoom in and out, your right mouse button, click and drag to move your scene around. So we're then going to skip 1 second, go to 1.5, right click again, add key. Got that bang on there, but we want this to be -1. So essentially we're dictating the up and down movement in terms of how long it will take in time and the actual interpolation in space as well. So we will need to set a final keyframe at 2 seconds. Just set the value back to 0, and that is essentially going to be our loop. Now at the minute Unreal has applied some linear interpolation, which means the up and down movement is going to be constant and quite robotic. So we want to make sure that we just select all of those keyframes so they go gold. Just right click on any of them, and we're going to set the key interpolation to auto, so that gives us a nice curve. Now this is not perfect. We have at the start and end, you'll see that the graph kind of tapers out, which will represent or denote a kind of a slow movement. Now, if we leave this as it is, when we loop our animation, there'll be a noticeable kind of pause as the object kind of moves up and down. So what I'll do is I'll not change this for now, just to kind of show you how leaving the graph like this kind of affects the movement. We do need to set this to loop because we do want this to loop over and over. But once we're happy with that, we can just close off the up and down motion tab. You'll now notice that we have this little pin here, which was not there before. It has the name of the track that we created, which will act as our alpha for our lerp. So the next stage is to actually set up the actual motion that we want. So we want the key to move up and down. So we're going to use, if we right click, a lerp node, which stands for linear interpolation, linearly interpolates. But the type that we want is our vector, so it's going to look at position data. So A will be our highest point, and B will be, well, A will be our lowest point, sorry, and B will be our highest point. The graph will then dictate over time how it actually reaches that based on the curve of the graph. So we do need to go back to the viewport to actually move the key off the ground. The world origin kind of denotes where the blueprint will meet the floor. So our default scene route, this white orb here, this will disappear when we bring it into the scene, but we will need to actually move the key upwards so that it's not sitting in the middle of the floor. So we're going to set its Z value to a value that we will be quite set and will be aware of. If we set this to 100, it's going to give us a meter off the ground. So back in the event graph, we can now say that the highest and lowest points will be based around that value that we've set for the key. So we want to try and maybe make it move about 10 to 15 centimeters up and down. So we want to make sure that the A value, the Z value, is set to 85, which will give us a movement of 15 units down, and the maximum value will be set to 115, so 15 units either way. We can wire in the up and down motion into the alpha, and then to actually apply this animation we'll need to tell Unreal Engine which object we want to actually move. So I'm just going to select the key static mesh object. I'm going to right click and just type in set relative location. So we want to set relative location. And that did not come across, but not to worry. We can just plug the key static mesh in there. We just want to wire up the update execution pin into the execution pin of the set relative location. Scene component. Okay, so let's wire in the return value from the lerp into the new location. And if we give this a test now, if we go back to the viewport, we can hit the simulation button. It did not work. I thought that might be the wrong node here. It's not a scene component. Let's have a look. Play. System there. So let's select the key static mesh. Make sure context sensitive is ticked on, and we want set relative look. That's it. That's the one we want. So set relative location. There we go. So let's just drag that in again, and our return location. Let's just compile that, and let's just test that again. There we go. So you'll notice as it bobs up, we have a very distinct pause at the end, and that's to do with the curve of our graph. And this is quite easy to fix by just changing the direction of the curve for the alpha. So we can just pause the simulation, jump back into the event graph, and just double click into our timeline. So the first thing we want to do is just flatten out the middle points. So double select those ones and right click on either of them and just use our flatten tangents command, and that gives us a nice even slope for the top and bottom. The next thing to do is a little bit more manual. We just want to focus on each of these points here, and the idea here is that we want to have a set path, set interpolation from the beginning point that matches the end point as well. So we want to have simulate continuous movement, and all we need to do is just drag and click and drag the handle, and you'll see that the one we selected and drag in is yellow. The idea here is that we want the direction of the actual animation curve to follow exactly the actual tangent, because the idea here is if we do the same on the other side, the curve will naturally flow and we'll get rid of that kind of little pause in the middle. So the same thing on the other side, obviously just the opposite way. There we go. So we get a nice curve on either side. Let's just jump back into the viewport and simulate that, and you'll see that we get no pop anymore, which is excellent. So just to make things a little bit more interesting, we can add some rotation. We don't want to program this in the same way that we programmed in the translate and the location. Unreal Engine actually provides, helpfully, a rotation component. So we'll just add this the same as our other components. And if we click on this, we can have a look at some of the values here. The only one that you really want to have a play around with are these rotation rate values here. So at the minute, the yaw is set to 180 degrees, which basically means that we'll get every second the object will rotate 180 degrees. So over 2 seconds, the key will rotate fully. So if we play our simulation now, we get a nice bobbing up and down motion, and every 2 seconds the key makes a full rotation. So that looks quite nice. You can have a play around with the yaw, the roll and pitch values. If you start playing around with these too much, the object will kind of look like it's swinging all over the place. So I would advise probably just to have a play around with the yaw, but that looks pretty good. Okay, so the next thing to do is just to program in some behavior in terms of what we want to happen when we overlap with this collision box. So back in the event graph, we're just going to make sure we have the collision box selected, and there's a couple of ways you can do this. You can right click and add an overlap event, or on the right hand side, if we just scroll all the way to the bottom, you'll see that we have events that we can simply add just by pressing these green buttons. So the one that we want is the begin overlap, and because we've got the collision selected, when we click this button, it will add a overlap event for this actual component. This is very important because it's specifying exactly which component we want to be overlapped, which is the collision box. So we just need to perform a cast operation. We're basically checking which actor we actually want to overlap. So what we're going to do is we're just going to click and drag from here, and we're just going to add a cast to node, and the player object within the scene that I'm using. I'm just using the first person template, so the character is actually the first person character. So if you're creating your own character, obviously your blueprint will have its own name, but if you're using the first person character, we just want to make sure that we're using the first person character blueprint. So we're going to cast to this to check, and we just need to make sure that the other actor field is plugged into the object. Now what we want to actually do here is we want to get rid of this object once we overlap. We're not going to do that straight away though. We are going to program in some functionality that will add keys to our player, so that we have basically a series of a count of the different amount of keys that we've picked up within the scene. So what we're going to do is I'm just going to nip over to the first person blueprint. So just into here, and this is one that I've done earlier. You can see over in the variables I've just added some variables here for the red, blue and green key counts. So just to quickly go over how you would create these, I'll just very quickly delete these out of here. You want to make sure in your variables you click to add a variable, rename it to what you want, red key count. I'll do this for one, and then obviously you can add additional functionality as you want. So we're just going to focus on counting the red keys. In fact, actually no, let's make all the different key types. That makes sense. We've created the different colors. So red, green key count, and blue key count. So Unreal Engine helpfully creates new variables using the previous type, so you only need to set it once, but the type that we have set it to here is integer, so it's basically just going to be a number value. So once we're happy with that, we just need to make sure we compile, which basically just allows us to configure these variables we've just created. So we basically want to say when we start the game, the default value for each of these key counts is obviously going to be 0. We want to start the game with no keys, and we'll add to each key as we pick them up. So let's just jump back into our key pickup again. So what we want to do here is we want to essentially check what color key we are using, and add a key to that value based upon the color that we return. So we need to make sure what we can do, just to keep things nice and tidy again, instead of connecting lots of other nodes from this pin here, we're actually just going to promote this the first person character casting here into its own variable, which we can then reuse. It'll store this value here. So we just want to drag off of the first person character and promote to variable, and it will create a new variable with no name. So let's just make sure, again, good housekeeping, we just rename everything. So FP character for first person character. And what we're going to do is, because we've got different key types, we're going to use a flow control node known as a sequence. Sorry. Now the sequence node essentially allows you to perform operations one after the other. So we want to create 3 pins because we want to check whether the key that we've picked up is a red key or a blue key or a green key. So we'll start with the red key. So we basically want to drag from the first pin, and we're going to perform an if operation. So we're going to use a branch. Now what we want to check is what type of key have we picked up, and that's going to obviously be based on the door key enumerator value here. So we want to right click and just type in equal sign, and the value, the utility that's selected, the equal enum, we'll just add that one in. We want to drag in our door key enum, and we want to get. And when we connect this pin into the enum will automatically read the values from this variable and allow us to change our selection based on the values that are set within the enumerator. So we want to leave the first one as red because we want to check to see if the key was red. So we're going to drag that in. We just want to try and keep everything nice and tidy. So essentially what we want to do is, if the key that we pick up is red, we want to cast or link back to the first person character and just add a value onto the red key integer. Ooh, just close that down. Accident. Right, so it's back into here. So what we want to do is we are going to just drag in our first person character variable and just get, and we want to drag out of here, and we just want to type in set red key count. So if the check is true, we want to set the key count. So we're just dragging off a true from the true onto the key, the execution pin, and what we want to actually do here is we want to add an integer. So we can just type in add int for integer plus integer, and we want to drag from the first person character the red key count again, but this time we want to get the red key count, because essentially what we want to do here is we want to set the key count by checking the original key count, which will plug into the first one there, and we just want to add 1 in that. When we set that to our red key count, that will now add a key onto our red key count. So it was 0 by default. When we pick up a red key, it's now going to add to our red key count. So what we're going to do here is, because this all looks good now, we're going to just comment this. So if we just click and drag all of these and just press the letter C on the keyboard, it will kind of package everything up into a nice little container that we can rename. So red, or let's have a look, if red key. And again, just to save yourself some time, we can actually just copy paste this. So Control W just to duplicate. Oh, make sure you have everything selected first. There we go. And let's just rename this one if green key. We will need to change these get and set nodes. So click off the first person character. So we want to set the green key count here. We want to get the green key count here. And we want to add 1 to this if it's true. And we want to do the same thing again for the blue. If blue key. There we go. So same thing again, just make sure you create these. So we want to set the blue key. And we want to get blue key. So we're going to add 1 to the blue key count, if that is true. So we obviously need to connect the sequence to each branch. And from each of these, we want to, once the key is picked up, once an instance of this key is picked up, we want to get rid of it from the scene. So we want to just create, right click and create a destroy actor node. And this is going to be whatever color key is selected. So we need to wire in, after we've set the key count, from each of these to destroy the key. So when we overlap with the box, if the character overlaps, if it's red, add to the red key. If it's green, add to the green key count. If it's blue, add to the blue key count. Oh, and let's just make sure we set the color that we're checking, otherwise nothing will happen. And irrespective of which key we pick up, we want to destroy the key afterwards. So it removes that instance of the key from the scene. And that's pretty much it for the key. So let's just compile that. No errors, which is all good. And we can close that for now. So the next thing to do is to create the door. So we're going to create another blueprint. Again, an actor, because we don't need any specific functionality. Let's just call this door BP. And double click into the door BP. So we need to add some geometry for the door. So we're just going to add a component, static mesh, rename as we go, and the collision component as well. So door, not door collision here, we want the box collision. There we go. I'll just rename that to door collision. So the door static mesh, we need to make sure that this is set to be a, let's have a look, we could use a cube. Let's have a look, a box, nope, let's use a cube. Let's have a look, one static mesh. Okay, so we've got a cube in. we want to make sure that the door, if we just switch to the front view, is obviously off the ground. So let's have a look. We could set, this is a 1 meter cube, so let's set it 50 centimeters off the ground. In fact, actually, no. Let's set the scale first. So 1 meter cube. If we want this to be 2 meters, let's set the Z value to be 2, and obviously the Z position to be 100 centimeters, so that the base of the door is on the floor. And let's just go back to our perspective. 1 meter wide for 1 meter wide for the width is fine, but obviously we don't want the door to be very thick. So let's just change the Y value down to something like 0.07. That should give us a nice thin door. Now, what's important to remember here is that we have created this static mesh. We've just loaded in a preset object from Unreal Engine. As such, we can't really change the pivot point. This is something that you would have to set up within your content creation program. A quick workaround would be to add a scene component. Now, a scene component essentially is a component that just has a transform. It just has a location, a rotation, and a scale. It has no visual representation in the scene, but you can use it to kind of facilitate different pivot points. So if we wanted to have our door rotate from the side, we could just add a scene node and then parent the static mesh into that scene node. Now, I'm not going to do that with mine. I'm going to create mine kind of as a Star Trek-y kind of swooshing door. So we'll probably be moving it on the x-axis from side to side. We do need to change the position of the collision box. Let's just make the Z value in terms of its extents. Let's just make this 200. Not 200, 100. I'm not really sure what scale factor this is using here. If we just position this now by, let's have a look, 50 centimeters or 100 centimeters. There we go. So the collider is the same size now, so it's almost as if the extents of the box are kind of half the size of the static mesh, but that's fine. We do want to make it a little wider though, so the X value, let's just click and drag that to make it a bit wider. Not too wide because we don't want the door to activate if we're stood over to one side, but we do want to make the Y value a little bit wider just so we've got a bit of space to stand in front of the door on either side so that it opens. So that looks good. Okay, so again, we'll jump into the construction script and we'll do the same as we did for the key. Let's add a variable called door and key enum. Let's set its type to be door and key enum so we can get those color values. And we want to do the same thing. We want to set a material for the door static mesh, and from the material we want to select, and we're going to use our door and key enum as our index. So the same thing again, just very quickly, just set up your materials. And blue. There we go. Now, the door and key enum in this blueprint is going to be required for a little bit more functionality than just setting the material. It'll actually be what we use to set what type of door the door is, for which key will unlock it. So that's all good for the construction script. Let's jump into the event graph. And again, we don't need any of these nodes here. We don't need the event tick. That's fine, but what we do need is a on collision overlap, on component begin overlap, sorry. So select the collision box, just add the component begin overlap to begin, and we're going to do the same thing as before. We're going to cast to first person to make sure we wire that actor into that field there as well. And what we're going to do here is we're going to essentially check what type of door we have, and whether or not we have the correct key to open that door based on the values that we have. So we're casting to the first person character. What we want to then do is we want to have a sequence node, because we're going to be doing a few things here. So a sequence node. So the first sequence node is going to look at whether or not we need the red key, or what type of key we've got. So what we want to do here is we want to run a branch, and the check that we're going to do is what type of door this door is. So we're going to run an enum, not enum, we're going to equals, get an enum check, and we're just going to run our door key. So we're just going to get that into here. So if the door and key enum is set to red, if that is true, we're going to run another branch to check how many keys we have. So what we can also do here is we can set a required amount of keys to be able to open this door. So we're going to have to set up another variable here, which we're going to create as another integer. So we're going to call this one required key amount. Just make sure that we set the required key amount to be an integer, and we're going to set that one to public, and we just need to make sure the door and key enum is also set to public as well, so we can change those values. And we're just going to hit compile just to get those all loaded in. Now the required key amount, you'll see here by default is set to 0. We're going to leave that as 0 because we're going to be able to change that on a per instance basis of this door. So what we need to do is we need to check whether the amount of keys is greater than the required key amount. So what we'll do, again, just to make this a bit easier, because we are going to have to get the key amount from the first person character, we're just going to move all of these over a little bit, just for a little bit of space. We're going to do the same as what we did with the key. We're just going to promote the result of this cast into its own variable, which will be contained inside the door. So let's just rename that to first person character, and let's just wire that in, just replace those. So we now have this set here, and that means that we can pull it back out over here as well. So we just want to get, okay. So what we want to get is the red key count. So remember, this is being set in the key blueprint. Whenever we pick up a key, the value is being added to, but the value is being stored in the character blueprint. That's why we've had to kind of make a reference to the character blueprint here so we can access this value. So we want to say the red key count. Let's drag off from the end here, and we want to check if the key count is greater than, so an arrow pointing to the right, if it is greater than the required key amount. So we can drag that in to the required key amount there. There we go. So if that is true, so let's just connect and wire that into the condition. If the red key count is greater than the required key amount, then what we want to do is we want to basically remove those keys and then open the door. So we want to, from our first person character, we want to set the red key count. So we're going to drag this into here. So you can see why it's a good idea to create this as a variable, because as you can imagine, having loads of wires connecting from here, things would start to get a bit messy, a bit confusing. So red key count, we want to set the key count. So that is from the from true. So what we want to do is we want to remove the required amount of keys from our key count. So we're going to right click and just type in int and then minus sign. And we want to minus the red key count. We want to minus the required key count from the actual key count we have, and then wire that into our actual key count. So we want to open a red door. If the door is red, we are checking to see if we have enough red keys. If it's greater than the required amount by the door. If that's true, we want to get rid of those keys, and then we want to open the door up. So what we're going to do is, from the red key count, we're going to just drag off, and we're going to create another timeline node. This is exactly the same as the timeline pretty much from the key. So let's just call this door open. Double click. And we're going to do pretty much the same thing. We want to add a flow track. We don't want it to be as long as this. We want it to be fairly short so the player isn't waiting for too long for the door to open. So at the start, at 0, we want to add a key. This will be where the door is closed. And at 1 second, we want the door to be open. So again, Unreal Engine will apply a linear curve. We want to make sure that this is set to auto to give a nice kind of animation to the door opening. You'll notice that we don't need to set this back to 0. Now this is because the door closing is going to be handled by the reverse input on the timeline, which we'll have a look at in a second. So let's just make sure that we just rename the track as well. So this is going to be door open or door transition. Doesn't really matter what you call it as long as it's something that you know. So door transition. We don't need this to loop either, so we don't need to tick that on. So once that's done, we can just close that. You can see that we have our door transition, and similarly, as we did before, I've decided that I want my door to move and not rotate. So I'm going to create a lerp vector, and essentially what I want to do here is my A value is going to be my my door closed position, So I just need to check and see what my actual location values are for the closed door. And we can see that it's 100 on the Z. And to open, what I want to do, if we have a look in the viewport, essentially what I want to have is the door move on the x-axis by its own width. So essentially we need to move it a minus 100. So if we jump back into the event graph, our open value is going to be minus 100 for the x, but it also needs to be 100 on the z as well. Otherwise, the door will sink through the ground as it moves to the left, which we don't want to happen. So we need to make sure that we just get a nice transition to the side. So we can hook our transition into the alpha, and as we did before, from the update pin, we just want to add a set relative location for the door static mesh. And let's just plug in the return value into that new location. Excellent. So this is now set up for the key count for the red key. So if the door is red and we have the required amount of red keys, we will play and open the door. Now, one thing that we can add here as well, at the minute, the present functionality is that when the door, when the key opens the door, if we don't have enough keys when we come back to the door, we'll never be able to open the door again. That's something you might want to program into your game, but personally I think having the door be unlocked once and then be able to be opened afterwards is a nice little touch. So we can control this by just adding in another simple variable, which we're going to put in at the start. We're just going to add in a Boolean variable, which is just an on-off switch, to basically state that the door will be locked by default before we open it, and then after we open it, it will remain open so that we don't have to reuse keys. So we just need to add another variable, just call this one door lock, and just make sure you change the pin type to Boolean. Compile your blueprint so that we can change the default value to be true. So this means that the door lock will be true. So if we drag this in now, we want to be able to we don't need to set it here because it is already set to be locked. We need to set this after we have opened the door. So we're just going to replace the pin here from the door lock to play, and make sure that you leave this checkbox unticked, because that is what is setting the door to be unlocked. We can then just pull in the red key from the execution from the red key count into the door lock, and that's pretty much it done for the red key. What we can do now though, as we did before, just for ease, we can comment. So this is if red door. Let's just select all of that. Let's just duplicate it, and we'll set this to be the green door. So if green door, and the same again. Let's just duplicate this and set this to be if the blue door. So if blue door. So we'll have to do as we did before, just get rid of any reference to the incorrect color. This is going to be our green key count, and we need to also set a green key count, so we can plug in our green key count into the greater than node and into the minus node, and this all gets plugged into the green key count. And our branch for true needs to get wired in to set. So again, the blue node, get blue node, blue count, sorry, and set blue count. There we go. So whack that into there, whack that into there, and just connect that up there as well. Set your branch from true, and just make sure your enum check is just set to the corresponding color. So if it's green, then we perform this. If it's blue, then we perform this. So we can wire in our sequence node into the branch, just add another pin, wire that into the blue door, and these can all then wire in to our door lock, and that just makes sure that we have everything kind of works irrespective of the color of the door. We do actually, just remember, we do need to do a check for the door lock, which we'll do at the start. So before the sequence, we're just going to connect this into another branch. So essentially the whole purpose of having the door lock check is that this sequence node is only triggered if the door is still locked, which it should be by default. So if the door lock is set to true, which it is by default, we then fire off the checks for what type of door it is and what key it is. If the door is already unlocked, we can just drag from the false directly into that play node there. So let's just move out of the way just so they can kind of see a little bit easier how that all connects up. So the door lock is only triggered, the door lock is unlocked after the key check is performed, but if the door is already unlocked, if the door lock is false, then we don't need to kind of perform any of this. We can skip right to the end. So just to make things a bit clearer, let's just change the color of these as well. We just change the color on the details on the sides, so we know that that's the red door. This is going to be the green door, and this is going to be the blue door. It just keeps everything nice and visually good visual information. So that's pretty much it for the door, systems. So we can compile that. That's all good to go. So let's just do a little check now to see how things work. So if we just close off our blueprints, I'm just going to get rid of any instances of previous doors that I had and previous keys that were in. So let's just get rid of all of those. So if we start putting in some doors, so door 1, door 2, and door 3. There we go. What you'll see here on the side for the instances that we've created in the scene, you'll see that they now have a value for the color, and by default set to red. So let's just set the middle one to green and see that the color changes accordingly within the editor, and the same for blue. And let's just drop in some keys as well. And just put one on the other side there. And if we set these keys, this key here, let's set this one to be green. Let's set this one to be blue. Now, just to check to see how everything works, we have set up a required key count as well. So let's say for the red door that we set it to be 2, we've got 2 keys in the scene, so naturally this door should work. If we set the green one to be 1, we've got one green key, so that should work. But let's just test to see what happens if we set the blue key, the blue door, sorry, to be 3. We've only got one key here, so if everything's been set up correctly, this door should not budge because we won't have enough keys to actually get this to kind of work properly. The branch node should trigger false. So let's just do a quick play. So if we run into the keys, you'll see that they disappear, which is excellent. That's what we want. We've got a red key, and we've got a red key here. There we go. So let's try and trigger the red door. So we have enough keys. If we move towards it, there we go. We see that the door moved to the side. If we move back, we have not put in the reverse node. Okay, so we'll have to put that one back in just to check the functionality. But let's just check with the green door as well. You see that the green door moved, which is excellent. And the moment of truth, the blue door, we only have one blue key. So if you move towards it, you see that it does not move, which is exactly what we want. That's great. So what we need to do now is, if we just exit, and let's just jump back into the door. We basically just need to set for our timeline what we want to happen once we're outside of the collision zone. So all we need to do is just select our door collision object. We want on component end overlap. So if you click and add that node in, and sometimes it does pop it off to the side where you don't want it. We're just going to bring this around here because essentially all we want to happen is if we are outside of the collision, we just want our timeline to reverse. So it's essentially going to look at whatever value it is between the -100 and the 0, and it will reverse from wherever. So if you step into the collision box and it doesn't quite reach the -100, maybe say it reaches -70, if you leave, it will play from that -70 back to 0. So that's why we didn't want to set anything up as a loop within the timeline. That's why we didn't want to set our curve for it to return to normal. If we compile that and just test. So if we approach the red door, we don't have enough keys. So let's just pick up our 2 red keys. And if we now overlap, see that the door moves, and if we leave the overlap, you see that the door returns back to normal. Now, because we've unlocked the door, we should now be able to step back into it, and it should move again for us. You see that it actually does open again without us having to actually acquire any more keys. So that's excellent. That's exactly what we want. So the last thing to do is just to set up a visual system for the screen, just so that we can actually see what's going on in terms of how many keys we have. At the minute, it's not very clear to the player how many keys you actually have. It's always good to kind of have that evident within the HUD, just so that information is there. So what we're going to do is, we're just going to create another blueprint here, but we're going to create this from the user interface menu here. We're going to create a widget blueprint. Now, what widgets are essentially visuals that you can overlay across the top of your screen with text or with images, but you can actually create bindings which will change the values of the text or the images that you decide to put within the widget. So we're going to call this one key widget. Just let this save. So let's just rename this to be key widget BP. And what we're going to do is we're just going to double click on it to open it up. Now, the widget editor is slightly different to your regular blueprints. You can see that there are two tabs here. One is your designer, which essentially just reflects what the visuals will look like on your screen. So at the minute you can see that we're using a 16:9 ratio. It is set to 1280x720, which means that the widgets will reflect this screen size. If you change the screen size, the widgets will not scale properly, but we're not going to worry too much about that. So we can change the screen size at the top here, but we're just going to leave it as it is for now. What we're going to do is we're just going to add some visual cues on here and then some text to reflect what's going on. So the first thing that we're going to need to do is just bring in some images. Now what I'll do is I'll just minimize my blueprint and we'll just import some images. So we go to import and we're going to go back to my source, so raw files, image source. Now these are just a couple that I created earlier. So we're going to use a blue, a green and the red key. Let's just open them in. So we have these in, and what's important about these is that you create these as PNGs, so that you have transparency around the actual image. Otherwise you'll get kind of unsightly blocks around your images. So if we just jump back into the key widget blueprint, first thing we're going to do is just add in an image. So if we click and drag this in, you'll see that you get a box that represents what the image is going to be. At the minute, just a white box. You can manually resize, or within your details just change the size X and Y. Now I want to make mine, I've made my source imagery as a 1:1 kind of square ratio document, so I want to reflect this within Unreal as well. So I'm just going to set my X and Y values to be the same, so I get a nice square image here. Now we're just going to place it over to one side, and I think what I'll do is I'll have my counts just stacked up in the bottom right corner. So I'm just going to copy and paste this a few times and just get this nicely lined up, and copy and paste again. There we go. So let's have a look. Just make sure they're roughly evenly spaced. Probably move that one up a little bit more. There we go. So each of these images at the minute, similarly to the static mesh component in the blueprint, they're in the scene, but we need to tell them what we actually want to appear, and that's just under the appearance and brush tab. So this might be collapsed at first. Just want to click on it to open it up, and you can just specify an image that you want to use. So the first one will make the red key. So if we just type in the word red, let's have a look. It might not have been called that. It might have been called key. So let's have a look. Where is it? Blue key. There we go. Key icon. So again, this is why you should name your files appropriately. So we can see that's loaded in, and because it was a PNG, you can see that there's nothing around the key. We've got this nice transparency, so that will overlay nicely within the scene. So just going to repeat the process again. Green for the green key, and blue for the blue key. There we go. So the next thing to do is just to create some text, and what we'll do with the text here is it will visually within the editor just show the words text, but we're going to create some functions that will bind to this text to change the appearance to whatever we want it to kind of say. So we're going to just create some text. So we're just going to click and drag some text in, and we're just going to minimize this a little bit. Don't worry if the text is disappearing, it doesn't matter too much. So we're just going to do the same thing again, just copy and paste these in, just get them all nicely kind of aligned up, copy and paste, There we go. So approximately there. Now what we're going to do with these is we're going to create some bindings to attach to each of these text elements. So to do that, if we have a look over in the details again, you'll see that you have this content section here. We can actually type in exactly what we want the word to say if we want it to just be static text. But just to the right, you'll see that we have this bind option here. Now, if we click on this, we don't have any functions, so we want to create a binding. When we click on this, it's going to open up our graph view, and you can just see on the left-hand side here, in the functions, we've now got a new function here. So we should rename these as we go, just to make sure that we are aware of what everything is. So this one's going to be our red key amount, and what we want to do is we're just going to move this return node out of the way. We need to grab that value of the key amount, which is stored within the first person character blueprint. So we're just going to, from the red key amount, we're just going to cast to first person. And this is slightly different to the blueprints before because we don't have an object to check. So what we want to do is we are casting to the first person character. At the minute, it's almost kind of like casting a fishing line out into the ether. We need to actually specify what it is that we're looking for here. So for the object, we're just going to click and drag off the object, and we're just going to type in get player character, and that will essentially look to see who the player character is and feed that into the object here. So what we want from the first person character is we want to find out what the current red key amount value is, and feed this as a string into the return node, which will then drive the change of the widget. So as first person character, I'm just going to drag off to here, and we just want to get red key count. So we're going to pull whatever the value currently for this is. So remember, it's going to be constantly changing based on how many keys we've picked up, whether they've been removed from using when we've opened doors. So this value is not set. Now all we want to do is just plug this straight into the return value, and you'll see that the pins here don't match in color. The green pins, this kind of light green, usually refers to integers, which is what the red key amount is. It's a number. And the pink pins refer to strings, so text values. Now essentially what we're going to do here is when we drag this wire into here, it's actually going to create a conversion node in the middle. So it's going to take the value and it's going to basically convert it out as a text into the return node. So that's all good to go. If we compile, everything looks good, and all we need to do now is just duplicate this function but change out what key count we want to pull through. So we can just right click and duplicate, just rename these as we go. So green key amount, just double click on it, not to rename. There we go, just to make sure we're on the green key amount, and we just need to delete out the red key reference and just get the green key count and just wire that into our text again, compile that, all good, and same again for the blue key amount. There we go. So again, let's just double click that to make sure we're working on the blue key amount, and let's just wire in get blue key. Excellent, there we go. So compile the last one, and let's just jump back into the designer view again. So we've got our key icons, and remember we can always come back in and resize these up. They do look a little small at the minute, but we'll just test this out. So we want to make sure on the red key that we are binding to the red key amount, on the green key that we are binding to the green key amount, and the blue key we are binding to the blue key amount. So if we compile that now, let's just minimize this, and moment of truth, when we press play, we have nothing. Now, this is because even though we specified the key widget blueprint, we actually need to specify when we begin play that it is attached to the screen. Now, widgets are usually attached to the player character, so we need to make sure that we jump into the first person blueprint just to specify. So you can actually see that I had one attached previously, but what we'll do is we'll just get rid of this just to do things from scratch. So you want to make sure that you use an event begin play node first. What this does is this essentially will trigger things as soon as you start playing, which is what we want. We want to make sure that our visuals, our HUD, is visible from the start of the game. So if we just wire in from the event begin play, we want, let's have a look, create widget, and the owning player is going to be get player controller, and the node that we want to construct, we just want to add widget component. No, that's not what we want. Select class, key widget blueprint. There we go. So add to viewport. There we go. Target is widget. So we're creating the widget, the key widget that we had created before, and then we're adding it to the viewport. So if we just compile that, let's have a look. Got an error. Blueprint is not itself. Oh yes, we need to just wire in the blueprint that we've created into the adding it to the viewport. So let's just compile that again. No errors, which is all good. So let's just have a play now, and you can see, yes, we've now got our keys right hand side. So let's go and try and pick up some keys, and let's see if we get the values that we want. If we pick up a red key, you can see that that added a 1 to our value. Now we've got 2 red keys, got 1 green key, and we've got 1 blue key. So let's try testing the doors out. So if we go to the blue door first, you can see that the door is still not opening because we set it to be 3 keys, and because we're not performing any action, we're not actually getting rid of any keys. We still have that 1 key there. If we go to the green door, we set the green door to have a value of 1. So if we open that up, you can see that the door opens and our key count now goes down to 0. If we then go to the red door, we set that up to be a value of 2. So if we move into the overlap, you can see that the door opens and our keys now go down to 0. So everything is working perfectly. So just to recap what we've done, we have created some materials. We created a base material with, just get this to open, with a vector parameter to help change our colors, and some metallic, some scalar properties which we can use to change the metallic, specular, and roughness. This material was then created into several instances, which allowed us to create individual varieties of colors. we then imported our meshes. We've created a key blueprint with the correct components. We've made a key that can bob up and down to give it a bit of interest, to provide a visual cue for players. That's something that they can pick up. We have performed some checks. So if we run over a key, we've performed a check to see which color it is, and then to add to a key count, which we set up on the actual player. So the first person player has some variables for the key counts, which get added to and removed from when we interact with the doors. We then created our door. So within our door, we added our components to create a visual door. We created some script to check which color door the door is, and whether or not we have the correct amount of keys to actually open the door, which is set as a public value that we can change per instance. We then created some code that will remove the keys from the player and open the door. And we've also put in a little failsafe, a little check to see whether if all doors should be locked from the start, and whether using keys will keep that door open. We created some animation for the actual door as well, what happens when you actually open the door. And finally, created a widget with functions that link our key values that we can have as bindings to change text on screen.